In the figure above, not drawn to scale, ABCD is a parallelogram such that vector DC is equal to 3x and vector DA is equal to 3y. The point P is on the line DB such that the ratio between DP and PB is equal to 1:2. Well, my first step is to pull out all of the information presented to me. Vector DC is equal to 3x, vector DA is equal to 3y. And figure ABCD is a parallelogram, which implies that vector AB is equal to vector DC, which is equal to 3x, and vector CB is equal to vector DA, which is equal to 3y. Part A1 of the question would like us to express in terms of x and y the vector AB. Well, we know that AB is parallel to the side DC. Therefore, vector AB is equal to 3x. Answer. Part 2 of A, we would like to express in terms of x and y in vector BD by moving along vector BA and coming down vector AD. Vector BD is equal to BA is in the opposite direction to vector AB. Therefore, vector BA is negative vector AB, plus AD is also in the opposite direction to vector DA. So this is plus a negative vector DA. BD is equal to negative vector AB, the negative of vector DA, which is 3y. BD is equal to negative 3x minus 3y. I can factor out negative 3 to simplify vector BD. Therefore, vector BD is equal to negative 3 times x plus y. Answer. In part 3 of A, we would like to express in terms of x and y the vector dp. Recall that the vector dp is equal to 1/3 the vector dp. In the previous example, we found the vector bd. Well, we know vector db is equal to the negative of vector bd. Therefore, the vector db is equal to the negative of negative 3 times x plus y. db is equal to 3x plus y, which implies that vector dp is equal to 1/3 of 3 times x plus y. Therefore, the vector dp is equal to x plus y. Answer. Part B, we would like to show that the vector AP is equal to x minus 2y. I can get to AP by taking two routes. I could go along the vector AB and come down the vector BP. Or I could get to AP by going down the vector AD and coming along the vector DP. I will find the vector AP by coming down the vector AD and going along the vector DP. Well, AP is equal to AD is in the opposite direction to vector DA, so this is negative DA, plus DP which we found earlier to be x plus y. AP is equal to negative 3y plus x plus y. Therefore, the vector AP is equal to minus 3y plus x plus y. AP is equal to x minus 2y. So we've just proven that the vector AP is equal to x minus 2y. Answer. Part C. Given that E is the midpoint of DC, we shall identify E here. Prove that points A, P, and E are collinear. To prove collinearity, we should be able to write one vector in terms of the other using a scale factor, and they must share a common point. I will be using vectors AP and vectors AE to prove collinearity. Previously, we found vector AP to be equal to x minus 2y. Let us now find vector AE. I will find vector AE by coming down vector AD and going across vector DE. So vector AE is equal to AD, of course, is in the opposite direction to vector DA, so this is negative vector DA plus vector DE. We know that E is the midpoint of DC, so vector DE is half the vector DC. Vector AE is equal to minus 3y plus half 3x. Vector AE is equal to minus 3y plus 3 on 2x. Here I could factor out the 3 on 2 and I would get vector AE is equal to 3 on 2 x minus 2y. This implies that vector AE is equal to 3 on 2. Recall, vector AP is equal to x minus 2y. AP. So, vectors AP and AE share the common point P. And vector AE is equal to 3 on 2 the vector AP. I could write vector AE in terms of vector AP by using a scale factor of 3 on 2. Therefore, points A, P, and E are collinear. That is our answer. Part D. Given that X and Y are 2 by 1 column matrices 2, 0, and 1, 1 respectively, use a vector method to prove that triangle AED is isosceles. A triangle is considered isosceles if two sides are equal in length and the two base angles are the same. Since we will be using a vector method to prove that triangle AED is isosceles, we shall find the magnitude of vectors AE, vector DE, and vector DA. Recall, vector AE is equal to 3 on 2 x minus 2y. Vector DE is equal to 3 on 2 x, and vector DA is equal to 3y. We shall begin with vector AE, which is equal to 3 on 2 x minus 3y. AE is equal to 3 on 2 times column matrix 2, 0, minus 3 times column matrix 1, 1. AE is equal to 3 on 2 is multiplied by every element in the column matrix. So 3 on 2 times 2, that is equal to 3. 3 on 2 times 0, that is equal to 0. Minus 3 times 1, that is equal to 3. 3 times 1, that is equal to 3. Therefore, AE is equal to, we'll be subtracting our 2 by 1 column matrix. 3 minus 3, 0 minus 3, which is equal to 0, negative 3. Therefore, the magnitude of AE is equal to the square root of x squared plus y squared, which is equal to the square root of 0 squared plus negative 3 squared, which is equal to the square root of 9, which is equal to 3. Next, vector DE, which is equal to 3 on 2 x. So we have 3 on 2 multiplied by 2, 0, which is equal to 3, 0. Therefore, the magnitude of DE is equal to the square root of x squared plus y squared, which is equal to the square root of 3 squared plus 0 squared, which is equal to the square root of 9, which is equal to 3. So, we have seen that the magnitude of vectors AE is equal to the magnitude of vector DE, which is equal to 3. We have proven that triangle AED is isosceles, and that is our answer.